Hi everyone, I'm Jenna Sweden, Industrial Account Manager at QA1.
And I'm Max Prusak, OE Field Sales Rep.
Our goal today is to equip you with the information you need to become the best rod end and spherical bearing resource for your customers. Rod ends and spherical bearings are everywhere in mechanical assemblies. We'll help you understand what they are, how they function, and what to consider when choosing the best option for the application.
We get it. You're asked to know a lot about the hundreds of product categories you sell, which is an impossible task. So our goal isn't to turn you into the all-knowing expert, but we do want to give you enough information so you can guide your customers through the selection process, make solid recommendations on simple applications, and know where to turn if you get in over your head.
But before we dive in, don't forget, at QA1, we are the experts in rod end and spherical bearings, and our products are readily available with 95% in stock and ready to ship. That's over 2,500 SKUs. Plus, we have some of the fastest lead times in the industry for customized components. This means we can maximize your customers' uptime and help keep them on schedule. So if at any time you hit a roadblock with another supplier or feel like you're getting in over your head, you can always reach out to the QA1 Industrial team. We're happy to provide guidance or directly assist in recommending a solution.
Let's get started by reviewing what rod ends and spherical bearings are and how they're similar. Both use the same basic mechanisms, a spherical ball that allows oscillation and misalignment under load. And both rod ends and spherical bearings include a through hole or bore for mounting a bolt or pin.
Also, both components rely on a ball that manages angular movement and carries radial loads. So internally, they're more alike than different, and the bearing mechanism itself functions exactly the same way.
Okay, so as Jenna just mentioned, a rod end includes a spherical bearing at its core, but the main difference is that rod ends have a housing with a male or female threaded shank for easy connections. Think of a rod end as being bolt-on ready, perfect for linkages where you need threaded attachment and easy adjustability. Because of this, they're used just about everywhere in industries like automotive, ag, construction, outdoor power equipment, industrial and manufacturing equipment, personal mobility, medical equipment, like I said, just about everywhere. In contrast, a plain spherical bearing includes only the ball and race with no body and no threaded shank. Instead of being installed directly, a spherical bearing is most often pressed or mounted into a housing or bracket, so this design provides a lot of flexibility for mounting. Spherical bearings are used in suspension arms, pivot joints, industrial equipment, and heavy-duty machinery.
So now that we understand the similarities and differences, let's take a deeper dive into rod ends. They may seem relatively simple, but they're available in a variety of materials and designs to suit different environments, load requirements, and even maintenance needs. Keep in mind, although different rod end designs share similar sizes and maybe even load ratings, their materials and construction significantly affect how they perform in real-world applications. That's why it's important to choose the correct rod end for the application. It ensures the best balance of durability, service life, and ease of maintenance. Rod ends are available in male or female threads, and material options include alloy steel, carbon steel, or even stainless steel. QA1 also provides a lightweight aluminum option. Our rod ends are also available in metric or inch dimensions. They come with self-lubricating liners for applications that don't require lubrication, or we also have rod ends with grease fittings for applications where regular lubrication is preferred. Also, most rod ends can be configured with a stud fitted into the bore, which can simplify things for your customers by offering an easy attachment point. Okay, let's talk about two-piece rod ends. Like the name implies, two-piece rod ends have two main components, the body and the ball. The body is wedged around the ball, which means the rod end body is mechanically formed around the spherical ball to capture it in place. This eliminates the need for a separate race, creating a permanent fit that maintains ball retention while still allowing smooth rotation and misalignment. One advantage of a two-piece rod end is that they're often the most economical solution. They're commonly used in light-duty applications with moderate load and low oscillation needs. With two-piece rod ends, you can choose from metal-to-metal construction or select a self-lubricating liner. Metal-to-metal options like our C-Series are simple and durable. However, regular maintenance like lubricating is recommended. As we mentioned, QA1 does offer two-piece options that include a self-lubricating liner between the ball and the housing. that offers the benefit of maintenance-free performance and helps reduce noise and vibration. In our two-piece designs, we offer a range of options. Our stainless steel G series with self-lubricating liner, often used when corrosion is a concern. Our C series carbon steel, available metal to metal or with self-lubricating liner. And lastly, our PC series high-strength alloy steel rod end, available in standard or high misalignment options. Metric size variations are also available in our C and G series rod ends.
Next up are three-piece rod ends. With three-piece designs, the ball is pressed into a sleeve, which is then swedged around the ball. The bearing is machined and then staked into the rod end body. The distinctive characteristic of the three-piece design is that the rod ends use a metal insert between the ball and housing. This insert is called a race. The big performance distinction is that three-piece rod ends with races have more material contact and better ball to race conformity. They're also durable under load and offer excellent wear characteristics. Again, you can get options with self-lubricating liners or grease fittings for easy lubrication. Our H series are made of high-strength alloy steel and are available with self-lubricating liners. K series offer the same precision tolerances of H series, but are made of a carbon steel. Our K series large bore options with 1¼ to 2-inch bore sizes are great for large-scale, heavy-duty applications. Our V series are carbon steel and include a bronze race that's a good choice for corrosive environments. And we offer metric options in our H and V series rod ends.
We also offer an injection molded rod end option. Our N series rod ends include a carbon steel body and use an injection molded nylon race between the ball and housing, offering an economical, self-lubricating solution for light to moderate duty applications.
Lastly, we'll talk about loader slot rod ends. These rod ends are constructed by inserting the spherical ball through a precision loader slot in the housing, which is followed by injecting a self-lubricating material. The unique combination design results in a best of both worlds, metal-to-metal support for heavy shock loads and very smooth operation for low loads, delivering improved load distribution and high wear resistance. The injection molded liner also provides lubrication and does a great job of sealing out debris and dirt. Loader slot rod ends are most commonly used in vehicle suspension and motorsports applications. QA1 X series rod ends are available in both inch and metric sizes. We also offer the A series loader slot rod end, which is made of aluminum, which can be used in applications where weight is a concern.
Now that we've wrapped up rod ends here are some quick rules of thumb to consider for choosing the right solution. For heavy-duty applications, you might start by considering loader slot or the alloy steel three-piece rod ends. For precision applications, think the three-piece rod end again, or maybe one of our self-lubricating options. And for cost-sensitive projects, consider a two-piece rod end. Now, let's shift to spherical bearings. Plain spherical bearings are used anywhere a pivot point needs to rotate, swivel, or misalign under load. Because they allow the ball to pivot inside the outer ring, they're ideal for applications where movement occurs in more than just a straight line. Typical applications include cylinder mounts, suspension pivots, steering knuckles, and industrial machinery. You would often use a plain spherical bearing when either the joint needs to pivot inside a fixed housing, or you want a solution that is pressed into a structure rather than threaded on, or you might even need misalignment capability but not an adjustable linkage. So we offer 4 basic types of spherical bearings: fractured race, commercial, precision, and unique dimension variations. The range of options also include alloy, carbon, bearing steel, or stainless steel. They come in metric and inch sizes, high misalignment variations, narrow and wide options, self-lubricating liners, and sealed options like our GEZ series. Also, most of our bearings are protective coated for corrosion resistance.
Let's start with fractured race bearings. They're made completely of hardened bearing steel and are QA1's strongest option. They're constructed by using a fractured outer race, which allows the race to be expanded during assembly, which holds solid during use. This construction method results in extremely precise fits and delivers very high load capacity. In addition to being extremely strong and durable, the hardened and ground surfaces allow for full ball to race conformity, resulting in reduced wear and smooth operation. Because of their strength and ability to handle high radial loads, shock, and oscillating motion, fractured race bearings show up in some of the most demanding industrial and construction or ag equipment.
QA1 COM spherical bearings are widely used in applications that require low friction and controlled misalignment. COM bearings provide good all-around performance in commercial applications and are made from alloy steel. COM bearings come with a groove in the race for grease distribution, while COM-T variations come with optional self-lubricating liners. Our COM-SS variation offers the same benefits as the rest of the COM series with the corrosion resistance of stainless steel. You would choose COM bearings for smooth, consistent operation with low friction and predictable wear. They're often used in industrial machinery where controlled movement is required.
Next up, our precision bearings are made from stainless steel and include self-lubricating liners. We offer narrow, wide, and high misalignment options. These bearings deliver tighter tolerances than COM bearings, plus the durability and corrosion resistance of stainless steel. This makes them ideal for applications that require long-lasting performance, but without the need for maintenance. You might find opportunities for these bearings in medical and mobility equipment, robotics, and specialized OEM machinery.
The last category of spherical bearings offer unique dimensions, and you might think of them as matching the construction of our three-piece K and H rod ends. All bearings in this category offer the same benefits of a COM bearing, but with non-standard dimensions. They can be specified with or without self-lubricating liners. Our MIB bearings are carbon steel and are a cost-effective, good general-purpose bearing. The AIB bearings are made from alloy steel. They're high strength and deliver high load capacity and excellent life under shock and oscillation. And lastly, the SIB bearings offer all of the same characteristics as AIB bearings, plus the corrosion resistance of stainless steel. These unique dimension bearings are used often in ag and construction, robotic arms, packaging, a range of OEM equipment, and more. So that's it. That's a high-level overview of our spherical bearing options.
While rod ends and spherical bearings are the foundational components of our industrial product offering, there's also a wide range of related products. We offer standard and custom ball joints, clevises and rod eyes, for joints that need a connection but without articulation, and then there are the accessories that help complete the interface between rod ends and spherical bearings, such as linkage rods, jam nuts, tube adapters, standard or high misalignment spacers. Combining these accessories with rod ends and spherical bearings can save your customer assembly time, money, and can make you the hero as you offer complete solutions for your customers.
Before diving into the selection process, let's spend a moment on part numbers. QA1 uses intelligent part numbering, so the part number values have real meaning. Let's look at this example of a rod end, the CFR8SZ. Reading from left to right, we see the letter C, which is the series of rod end, in this case a two-piece rod end. Next we see F, which means this rod end has a female thread. After that is the letter R, which signifies right-hand thread. After thread is size designation. In this example, we see the size number is 8, which means ½ inch. It's important to remember all rod ends, unless metric, are measured in 1/16. Lastly, in this example, the letter S means this rod end has a stud, and the letter Z for a grease fitting. So the CFR8SZ rod end includes both a stud and a grease fitting. For metric rod ends, the letter M will be the first letter in the part number. And for self-lubricating options, the letter T will be at the end of the part number. Spherical bearings are very similar, but a little simpler because they have fewer variations. Again, reading left to right, if there is an M, it means metric. The series comes next, in this example, COM. The size follows after, again, a number designation. And lastly, if the bearing includes self-lubricating liner, it will include the T identifier at the end. So that's it, believe me. It may feel a little intimidating at first, but it gets pretty simple once you spec a few.
Okay, we're in the home stretch. Now that you've got all the information of what options are available and how some of these options might be used, let's take a quick look at what factors to consider when specifying. I'm sure you've been taking diligent notes, but if not to worry. You can find all this information and much more in the QA1 Industrial Catalog. We'd be happy to send you a print copy, or you can always find the most up-to-date edition on our website, QA1.net. The first path we'll call the easy button. As the name implies, it's pretty simple. If you know a competitive part number, such as the one that you or the customer has been ordering previously from a different supplier, you can look that up in the Competitor Product Interchange Guide, included in the QA1 Industrial Catalog. When looking at this table, you find the corresponding QA1 product family and then just choose the corresponding size and configuration. It is just that easy. If you're not starting with a competitive part number, the following questions can steer your customers to the right solution. And remember, if at any time you get in over your head, just pick up the phone and give us a call.
With the second path to specification, start by asking your customers if they know the load requirements. You'll need to choose an option that delivers the appropriate load capacity for the application. Load requirements will often drive material choice. You must consider the application's need for strength and corrosion resistance. Next, think about motion type and misalignment angle. For high misalignment applications, opt for designs that allow for more angular flexibility. Also important are environmental conditions and maintenance needs. If the environment is harsh, sealed or self-lubricating designs would be the best fit. Another factor is cost. Consider the trade-offs between initial cost and long-term performance. Lastly, you'll want to think about configuration. Can you save your customers time and money or increase performance by configuring with studs, grease fittings, or even a pre-assembled linkage component? So that's it, folks. You made it, and now you're experts. Or at least you've got enough information to be able to talk intelligently to your customers about rod ends and spherical bearings. And you know where to go if you need more information. Speaking of that, we'd like to take a moment to introduce Jeff Diaz.
Hi everyone, I'm Jeff Diaz, QA1 Industrial Product Manager. I've been working on rod ends just about my entire career. So remember, if you get in over your head and just don't know where to turn, call or email. We're here to help.
Because when it comes to rod ends and spherical bearings, QA1's got you covered.